The idea of parallel universes has fascinated scientists, philosophers, and storytellers for centuries. Could there be other versions of reality where different choices were made, different histories played out, and different versions of ourselves exist? While this concept was once purely the domain of science fiction, modern physics suggests that parallel universes may not just be possible, they might be inevitable. From quantum mechanics to cosmic inflation and string theory, multiple areas of theoretical physics point to the possibility that our universe is not the only one. Some theories propose that countless other universes exist alongside our own, each with its own physical laws and variations of reality. Others suggest that every decision we make spawns a new universe, leading to an infinite web of alternate timelines. But if parallel universes do exist, how could we ever detect them? Are there signs hidden in the cosmos that hint at their presence? Could black holes, wormholes, or anomalies in the cosmic microwave background be clues to other worlds? Scientists are actively exploring these questions, and while definitive proof remains elusive, the idea of a multiverse is gaining serious attention in modern physics. This journey into parallel universes will take us through theoretical physics, strange cosmic phenomena, and the limits of human understanding. If they exist, what do they mean for our place in the cosmos? Are we just one of infinite possibilities, or does our universe hold a unique significance? The answers may be stranger than we ever imagined. The concept of parallel universes is not a recent invention. It has existed in philosophy and science for centuries. Ancient civilizations speculated about the possibility of multiple worlds, but the idea truly gained traction in the 20th and 21st centuries as advancements in physics challenged our understanding of reality. One of the earliest philosophical ideas resembling the multiverse hypothesis came from ancient Greece. The philosopher Anaximander in the 6th century BCE suggested that countless worlds might exist, forming and disappearing in an eternal cycle. Later, medieval and Renaissance scholars, including Giordano Bruno, speculated that the universe was infinite and could contain countless worlds beyond our own. However, these ideas were more philosophical than scientific, lacking the mathematical foundation needed to be taken seriously by modern physicists. The modern scientific discussion of parallel universes began with quantum mechanics in the early 20th century. Physicists realized that at the smallest scales, particles don't behave in a predictable way. They exist in multiple states at once until observed. This bizarre property led to the many worlds interpretation, which suggests that every quantum event creates a branching reality, where all possible outcomes occur in separate parallel universes. At the same time, developments in cosmology and general relativity introduced new ideas about space-time and its structure. The inflationary model of the universe, proposed by Alan Guth in the 1980s, suggested that during the first fractions of a second after the Big Bang, space expanded at an exponential rate. If this inflation happened in different ways in different regions of space, it could have created multiple, disconnected universes, each with its own set of physical laws. Further support for the multiverse idea came from string theory, which predicts that our universe may be just one of many existing in higher dimensional space. In this view, what we perceive as reality is just a small slice of a much larger, hidden structure. Some versions of string theory even propose that universes can collide and interact, potentially leaving observable evidence in cosmic radiation. As our understanding of physics has evolved, the multiverse hypothesis has moved from philosophical speculation to a serious scientific discussion. While still unproven, multiple theories suggest that the reality we experience may be just one of countless parallel worlds. But how do these theories actually work? The next step is to dive deeper into quantum mechanics, one of the strongest arguments for the existence of parallel universes. Quantum mechanics, the branch of physics that describes the behavior of particles on the smallest scales, is one of the strongest scientific arguments for the existence of parallel universes. Unlike classical physics, where objects follow predictable paths, quantum mechanics introduces a world of uncertainty and superposition where particles can exist in multiple states at once until observed. This bizarre phenomenon led to the development of the many worlds interpretation, one of the most intriguing theories about parallel universes.
The foundation of this idea lies in the famous double-slit experiment. When light or particles are passed through two slits, they create an interference pattern, behaving like waves. However, when scientists attempt to observe which slit a particle goes through, the pattern collapses, and the particle behaves like a single point rather than a wave. This suggests that before observation, the particle exists in multiple states simultaneously. In 1957, physicist Hugh Everett III proposed the many worlds interpretation as an explanation for this behavior. According to MWI, every quantum event, every decision, every measurement results in a splitting of reality where all possible outcomes occur in separate parallel universes. For example, if a particle has a 50% chance of moving left or right, then both possibilities happen, but in different universes. One version of reality observes the particle going left, while another version observes it going right. This means that with every quantum event, the universe branches into multiple realities. If MWI is correct, then there is a universe where you chose a different career, another where Earth never formed, and another where life evolved completely differently. The number of parallel universes would be infinite, encompassing every possible variation of existence. Unlike other interpretations of quantum mechanics, the many worlds interpretation removes the need for a collapse of the wave function. Instead, it suggests that all possible states continue to exist, but in separate, non-communicating branches of reality. This interpretation has gained popularity among some physicists because it preserves the fundamental laws of quantum mechanics without requiring special rules for observation. However, there are challenges to this theory. One of the biggest criticisms is that we have no way to test or interact with these parallel universes, making it difficult to prove their existence. While quantum mechanics strongly suggests the possibility of many worlds, the lack of experimental evidence keeps it in the realm of theoretical physics. But quantum mechanics is not the only scientific field suggesting the possibility of multiple universes. Another compelling idea comes from cosmic inflation, which suggests that entire universes may be forming all the time, completely separate from our own. Another major scientific framework supporting the idea of parallel universes comes from cosmology, specifically the theory of cosmic inflation. This theory describes the ultra-rapid expansion of space in the earliest moments after the Big Bang, and it suggests that our universe may be just one of many that formed in this way. The concept of inflation was first proposed by physicist Alan Guth in the 1980s to explain several mysteries of the universe, such as why space appears uniform in all directions and why the cosmic microwave background radiation is so evenly spread. Inflation theory suggests that within the first fractions of a second after the Big Bang, space expanded exponentially, stretching tiny quantum fluctuations into large-scale structures like galaxies and cosmic voids. But here's where things get interesting. Inflation may not have stopped everywhere at the same time. Instead, some regions of space may continue to inflate indefinitely, while others stop and form bubble universes, each one a separate cosmos with its own laws of physics. This process, known as eternal inflation, suggests that our universe is just one bubble in an ever-growing cosmic foam with countless other universes forming alongside it. If this theory is correct, it means that other universes may have completely different physical laws, constants, and even dimensions. Some could resemble our own, while others could be so radically different that life, matter, or even time itself wouldn't exist in any recognizable way. Some models even suggest that new universes are being created constantly, expanding from quantum fluctuations into fully formed realities. One of the biggest implications of the bubble universe theory is that it could explain why the laws of physics in our universe seem so perfectly tuned for life. This is known as the anthropic principle, the idea that we observe a universe that allows life simply because we exist in it. If there are countless other universes, most of them may be lifeless, but we happen to be in one where the conditions are just right. However, just like the many worlds interpretation of quantum mechanics, the biggest challenge with this theory is that we currently have no way to observe or interact with other universes. Some scientists believe that if two bubble universes ever collided, it might leave detectable evidence in the cosmic microwave background radiation, the afterglow of the Big Bang. While no such evidence has been found yet, researchers are actively searching for signs of such an event. If the inflationary multiverse is real, it means that our universe is just a small part of an unimaginably vast cosmic landscape. But there's another theory, one that suggests not only multiple universes, but multiple dimensions. Could extra dimensions be the key to unlocking the secrets of the multiverse? That's where string theory comes in. String theory is one of the most ambitious attempts to unify all of physics, and it introduces a radical possibility, the existence of extra dimensions beyond the familiar three of space and one of time. If true, this could provide a profound explanation for the multiverse and why we may never detect parallel universes directly. At its core, string theory proposes that the fundamental building blocks of reality are not particles, but tiny, vibrating strings. These strings exist in higher dimensional spaces, meaning that our universe may be part of a much larger structure hidden from our perception. According to most versions of string theory, the universe must have at least 10 or 11 dimensions for the math to work. The extra dimensions are thought to be curled up at microscopic scales, making them invisible to us. But why does this matter for parallel universes? One of the biggest breakthroughs in string theory is the concept of brain cosmology. In this model, our universe is just one three-dimensional brain floating in a higher dimensional space, often called the bulk. There could be countless other brains, each representing a separate universe, possibly with different physical laws. These brains could be close to each other in higher dimensions, but we wouldn't be able to see or interact with them directly, except under special conditions. Some versions of string theory propose that collisions between brains could create new universes or even have caused the Big Bang itself. This idea, called the ekpyrotic universe, suggests that our universe was born when two higher dimensional brains collided, releasing an enormous amount of energy. If this is correct, then universes might be constantly forming, merging, or even influencing one another. Another intriguing possibility is that gravity might be able to leak between universes. Unlike other forces like electromagnetism, which are confined to our brain, gravity could extend into the higher dimensional bulk. If true, this could explain why gravity is so much weaker than other fundamental forces. It is being distributed across multiple dimensions. Some physicists have even proposed experiments to detect gravitational anomalies that could indicate the presence of parallel worlds. However, string theory remains highly theoretical, and no direct evidence has been found for extra dimensions or brain universes. But if these ideas are correct, they could provide a scientific basis for a multiverse that is even stranger than we ever imagined, one where our reality is just a small piece of a much larger hidden structure. With multiple scientific theories pointing toward parallel universes, from quantum mechanics to cosmic inflation to string theory, the big question remains, is there any actual evidence? Could we ever prove the existence of a multiverse? Scientists are searching for clues that could provide a definitive answer. While the concept of parallel universes is fascinating, scientific evidence remains the biggest challenge. Physicists and cosmologists have proposed several ways we might detect the existence of a multiverse, but so far, no direct proof has been found. However, that doesn't mean there aren't intriguing clues that suggest our universe might not be alone. One possible source of evidence comes from the cosmic microwave background, the afterglow of the Big Bang. If our universe is just one of many in an inflationary multiverse, it's possible that another universe has collided with ours in the past. This could leave an observable bruise in the CMB in the form of unusual temperature variations or circular patterns. Some scientists have claimed to find hints of such anomalies, but so far nothing conclusive has been confirmed. Another potential way to detect other universes is through gravitational waves, ripples in space-time caused by extreme cosmic events. If parallel universes interact in any way, They might produce unique gravitational signals that we could detect using advanced observatories like LIGO and the upcoming LISA, the Laser Interferometer Space Antenna. If gravity truly leaks between dimensions, as some string theorists propose, it could provide strong evidence for higher dimensional universes. Quantum physics also offers some strange possibilities for testing the multiverse hypothesis. Some experiments suggest that particles can behave in ways that are best explained by interactions with other universes. For example, the famous double-slit experiment shows that electrons can act as if they are passing through multiple paths at once, leading some scientists to speculate that they are interacting with their counterparts in parallel realities. However, this remains a controversial interpretation. There's also the mystery of dark matter and dark energy, which make up about 95% of the universe's total mass energy, yet remain completely undetectable except through their gravitational effects. Some physicists have suggested that dark matter could be ordinary matter from a parallel universe, interacting with our universe only through gravity. Others have proposed that dark energy, the mysterious force driving the accelerating expansion of the universe, could be a sign of interactions with a hidden cosmic structure beyond our observable reality. Despite these potential clues, the biggest challenge remains: how do we test or observe something beyond our universe? Some physicists believe that with future advancements in quantum computing, cosmology, and particle physics, we may one day find concrete proof of parallel universes. Until then, the multiverse remains one of the most compelling and mysterious ideas in modern science. But what would it mean for us if the multiverse is real? Would it change how we see ourselves, our place in the cosmos, or even our understanding of reality itself? These philosophical implications are just as fascinating as the scientific ones. If parallel universes exist, the implications for humanity and our understanding of reality are profound. The idea that our universe is just one of countless others raises deep philosophical questions about our significance, free will, and even the nature of consciousness itself. One of the most thought-provoking consequences of the multiverse is the possibility of infinite versions of you. If the many worlds interpretation of quantum mechanics is correct, then every decision you make spawns a new universe where an alternate version of you makes a different choice. This means that every possible version of your life exists somewhere, a world where you made different career choices, met different people, or even lived in. This raises the question, what does it mean to be you? If there are infinite versions of yourself in different universes, does that diminish the importance of your choices in this reality? Or does it mean that every possible outcome is meaningful in some way? Some philosophers argue that if infinite versions of us exist, then our identity is not fixed. We are just one possibility in a vast sea of realities. The multiverse also challenges traditional religious and existential beliefs. Many world religions describe a single creation, a single divine plan. But if there are infinite universes, then there could be infinite versions of that plan, or none at all. Some argue that this reinforces a scientific, naturalistic view of reality, while others believe it expands the possibilities for spiritual or theological. Another mind-bending implication is the Boltzmann brain paradox. If the multiverse is infinite and chaotic, then it is statistically possible that fully formed self-aware consciousnesses, like your own, could spontaneously arise from random quantum fluctuations. If this were true, then you might not actually be living in a real, structured universe, but rather in a temporary bubble of ordered reality that will eventually dissolve into nothingness. While this idea is purely speculative, it raises fundamental questions. Then there's the idea that if multiple universes exist, some of them might be vastly different from our own, with different laws of physics, different fundamental forces, or even different kinds of life. This raises the question, why does our universe exist in a form that allows life to emerge? Some scientists argue that the answer lies in the anthropic principle, which suggests that we observe our universe the way it is simply because it's the only kind of universe where intelligent observers like us could exist. If the multiverse is real, it would mean that reality is far stranger and more complex than we ever imagined. It would mean that everything we think of as unique, our planet, our history, even our own existence, is just one possibility among an unimaginable number of others. Would this make life feel less special, or would it make our experience of reality even more profound? Regardless of whether we ever find definitive proof of the multiverse, exploring these ideas pushes the boundaries of science, philosophy, and human imagination. It forces us to confront the biggest questions of all. What is reality? Why do we exist? And is our universe truly unique? Are we alone, or just one of many? The idea of a multiverse is one of the most profound and mind-bending concepts in modern science. Whether it emerges from quantum mechanics, cosmic inflation, string theory, or even philosophical thought experiments, the possibility that our universe is just one of countless others reshapes everything we think we know about existence. If parallel universes are real, they challenge our understanding of identity, free will, and the nature of reality itself. Though we have intriguing clues, from cosmic microwave background anomalies to strange quantum behavior, there is still no direct evidence proving the multiverse exists. Future advancements in physics, such as improved gravitational wave detection and quantum computing, may one day bring us closer to answering this ultimate question. Until then, the multiverse remains an extraordinary possibility, one that fuels scientific discovery and human imagination. But even if we never find proof, contemplating the multiverse forces us to confront an even greater question. What does it mean to exist at all? Whether we are alone in the cosmos or part of an infinite web of realities, one thing is certain: our quest for knowledge will never stop, and the universe, or multiverse, will always have more mysteries waiting to be uncovered.